Hello, you are welcome to Mike's Physics Math channel. That is the PM channel. If you are watching it for your very first time, that is the channel. And please don't forget to love this video, subscribe to it, share it to others. Please, I'm going to solve a question on simple AC circuit. And this is the question. The question reads, the resonance frequency of an AC circuit is 1000 kHz. If each of the capacitance and inductance in the circuit is reduced by 50% and no other changes are made, the resonance frequency will become, so we have to find the resonance frequency when the capacitance and the inductance are reduced by 50%. So the solution. First of all, what we have in the question, we are given the resonance frequency which is denoted by F0 and is given as 1000 kHz. So let's convert it to Hertz because frequency is measured in Hertz. So when you multiply this one by 1000, you have 1000 times 1000 will give you 1 million. That is equal to 10 raised to power 6 hertz. So this is the frequency, the resonance frequency. Now the form of finding resonance frequency, we have F0 is equal to 1 over 2 pi the square root of LC. That is the inductor times the capacitor. Now in this expression, we are given the first fundamental or the resonance frequency. So we have to form an equation here so that I can solve for both of them when the capacitance and the inductance are reduced. So in this case, we know that 1 over pi, 1 over 2 pi is equal to K, which is equal to constant, which is equal to a constant. So it means that I can write this equation 1 over F0 is equal to K over the square root of LC. Now to make K the solid of the formula here, we can say K is equal to, that's the cross multiply, F0 times the square root of LC will give you F0 the square root of LC, and the frequency here is given as this. So this will be equal to 10 raised to power 6 times the square root of LC. So let's assume this is equation 1. Now for the second statement that says this capacitance and the inductance in the circuit is reduced by 50%. It means that this one can be over 2. That 50% is 5, or that's 50 over 100, and that will be 1 over 2. So now the capacitance and the inductance are reduced by half. So we can use the same equation here where we say that K is equal to F0 LC, the square root of LC. By doing so, we can now have K is equal to F0, the square root of L over 2 times C over 2. You know that LC means L times C. And these two of them are reduced by half. That is 50%, which is half. Now, we can now equate this coefficient. We can equate the two together. F0 and the F0, the K that we have gotten here. Both of them are values of K. So K equal to this, and then K is also equal to this. And by doing so, if you substitute into this expression, we can have F0 now be equal to, from this equation, F0 will be equal to 10 raised to power 6, the square root of LC over, this is the denominator, will have the square root of L over 2 times C over 2. So we can simplify this one further. This is equal to 10 raised to the power 6, the square root of LC over the square root of LC over 4. So mathematically, this can be written as 10 raised to the power 6, the square root of LC over the square root of LC over the square root of 4. Now, we can know in the real sense, this root 4 can multiply the numerator here. When you write it in division sign and when you introduce the multiplication sign, this will go up. So you are multiplying F naught, or let me write it that way. We can have 10 raised to the power 6, the square root of LC divided by the square root of LC over the square root of 4. Now, this can be written as 10 raised to the power 6, the square root of LC times root 4 over the square root of LC. So now you can see that this and this, this is the numerator, this is the denominator, so they can be able to cancel out. So we are now left with 10 raised to the power 6 times the square root of 4 is what? Is 2. Is 2. So we can now have 2 times 10 raised to the power 6. And 2 times 10 raised to the power 6 is what? 2 times 10 raised to the power 2, that is 2 million. 2 million. So that is 2 million hertz. So writing it in standard form, you can write it this way. This is 2000 or 2000 kilohertz. So this is the resonance frequency as required when the capacitance and the inductance are reduced by 5 or by 50%. I hope you enjoyed this solution, and please don't forget to subscribe to this channel, share these videos, and follow me so that you can watch more of this and learn. Have a lovely time. Love you. Bye.